of inertia of the shape about its own neutral axis. So IO is going to be BD cubed over 12. That's why I put these this way. BD cubed over 12. 4 times 1 cubed over 12. 1 times 8 cubed over 12. BD cubed. So IO is the moment of inertia of the individual part about its neutral axis. So this is a third. And 8 cubed divided by 12 is 42 and a bunch of sixes. That's 2/3, so this is 43. Add those two together. Okay, that takes care of that part. So this is IO plus AZ squared. So plus AZ squared equals IO plus AZ squared equals I. Okay? Z. Now this is a bear for a lot of students. Hopefully you get it. Let me tell you what it is. It's the dimension between this neutral axis and the center of the part. Okay? So Z1 is right here. Distance between the neutral axis and the center of the part. Z2 is right here. Neutral axis in the center of the part. So somehow I've got to be able to calculate Z1 and Z2. So let's look at it. What do I have? I've got a nice little picture over there. I like what I see. Let me see what I've got. Y1 was 8.5. Y2 was 4. Okay, what do I have? Do I have enough data up there? Z1. Looks like if I take 3.5 and subtract 1/2 from it, I've got Z1. That looks to be 3. Over here, if I take 5.5 and subtract 4 from it, 5.5 minus 4 should give me that, so this looks to be 1.5. 5.5 minus 4. There's that. Now all I got to do is do the math. AZ squared. AZ squared. So I'll take 4, multiply it by 3 squared, get 36. 8, multiply it by 1.5 squared, and get 18. Add the two together and get 54. Take 43 and add 54 to it and get 97 inches to the 4th. Move 97 right into here. Do the math. And I think you got her done. So let's look at the math. Now, I would implore that you put this in the equation because you're going to forget it. This M is in foot-pounds. Put this 12 inches per foot as part of the equation so you don't forget it. Okay, I'm going to take 16,125 times 12 times 5.5 and divide it by 97. 10 10,972 psi. Move down to the bottom, 3250 times 15.125 divided by 97 and 1, 506.7. There's my shear stress, 507. And there's my bending stress, 10,972. So you can see this particular problem, the work was centered around the shape and not around the moment and shear. I use page 114 to get those two numbers. I had to draw a table to get the rest of the numbers. So hopefully that gives you a snapshot of why you've been doing all these parts. All these parts assemble into the ability to fill in the blanks for the stress equations. Now we're going to take the actual stress, compare it to allowable, make sure that we've got enough capacity. If the numbers vary by a lot, if this is great big and this is small, I'm going to use a smaller number. If this number is small and they're relatively close, like if this is 12,000, I would use what I've got. If this is 50,000, I would back the size down. So the stresses tell us whether we've got an economical decision, and the size we picked does the job and cost-wise is economical. So why don't you take a look at this video, finish up your homework problems. I'll be on one more time before we have the next test. The next test is going to be, if you want to get ahead of me a little bit, is going to be a function of Unit 2. And I've got one more thing to do yet, and that's it. And I'll be on board this weekend, most likely. Test 2 is going to be Chapter 2 and Chapter 3. Chapter 2 is going to be 2.1, 2.2, and 2.6. Axial stresses, axial deformation, trusses, member forces, reactions, and joints. Chapter 3 is going to be reactions, shear and moment, cross-sectional properties, and the stress equations, FB and FV. And that should get us out of that, except for we've got one straggler unit that I'm going to catch, and I'll probably be online to do this one. It is Chapter 3, and if you go to the back, it's Chapter 3.9, I believe. I'll be there in a second. Chapter 3.9, yes, and it's biaxial. It's bending and axial stress, so Chapter 3.9. So up till now, after you get done with these problems, we've covered everything except for this guy right here. We'll catch him before the next test, and you'll be all set. Thank you. Take care.